Greetings, traveler. I'm the Calculus Cleric, and today we'll be going over integrals in arc length. So the specific problem is to calculate the length of the asteroid x to the 2/3 plus y to the 2/3 is equal to 1. And they give us a helpful graph of the asteroid beneath. And what this graph can tell us is that this is a symmetrical shape. So we can just find the arc length of one of these sides and then multiply it by 4. So the first step in finding the arc length is to use the formula, which I'm going to write down right now. So this is the formula for the arc length. And so the first thing we're going to need to do is find f prime of x. So we have this equation over here, and what we're going to do is we're going to take the derivative. Notice that it's in respect to x, so we're going to do the same thing on our side. So taking the derivative of x is just 2/3, x to the -3/3 because it's -1, which means -1/3 once we subtract 1 from 2/3. And then we find the derivative of y, which will be the exact same thing as the exponent is the same. There's just one small extra bit. It's because we're differentiating with respect to x. But since we're differentiating with respect to x, and this is a y, we simply have to take the derivative of y, which we write as dy over dx, and we can just leave it like that. And then the derivative of 1 is 0. And then moving on, now we go on to the next step, which is to solve for f prime of x, which is why we're taking the derivative of this. So we can replace this with y prime of x, which will be equal for our purposes to f prime of x. And so we just use algebra from here to solve that out. So subtracting -2/3 from both sides of the equation, well, -2/3 x to the -1/3. Replace dy over dx with y prime. And then to isolate y prime by itself, we divide both sides by 2/3 y to the -1/3. Rewriting this. So the 2's will cancel out, the 3's will cancel out, leaving us with only a y to the 1/3 over x to the 1/3. And I can't forget the negative sign. Okay, and so that's our y prime. Now it's time to go plug it back into the equation. So s is equal to, okay, let's define the bounds. So let's pick this side because I don't want to deal with any negatives. Okay, so this goes from, it looks like it goes from 1 to 1, but we have to be careful because we're taking this with respect to x, right? So our bounds are going to be in terms of x, and then we shouldn't count y's in this at all. So we should start from here, which is 0. Let me put that on the bottom. And then we're going to go out to 1 in terms of x component. So it's 1 to 0. Since we're taking this in terms of x, and then we just slap our new y prime in there. And we square that. And let me rewrite that out again. But we're going to get rid of the square. So it'll be y to the 2/3 over x to the 2/3 dx, and the negative sign disappears because when you square something, the negatives will cancel out. And then from here, we just simplify this algebraically. So let's set the denominators equal to each other. X to the 2/3 plus y to the 2/3 all over x to the 2/3, because I made 1 into x to the 2/3 over x to the 2/3 and combine the denominators. Okay, now there's a little problem in which we don't want y in this at all because we only want to take things with respect to x. But that can be solved simply by using this equation over here. So we get y to the 2/3, and then we solve for it. So we subtract x to the 2/3 from both sides of the equation, giving us 1 minus x to the 2/3. And so we just plug this in for y to the 2/3. And then from there, the x to the 2/3 and the negative x to the 2/3 will cancel out, leaving us with the square root of 1 over x to the 2/3 dx. And then from here, we just evaluate the integral. Although we can take a smarter move first, which is to delete the square root, because this is still squared. So in other words, you can rewrite this like this. And the answer will be the same as above. And then the squares and the square root can cancel themselves out, leaving us with only 1 over x, the 1/3 dx. And then from here, we can just, well, as I said earlier, we can evaluate the integral. Convert this to x to the negative 1/3 for more ease. And then add 1 to the negative 1/3. And then have that result on the bottom as well. I should get rid of the integral sign, seeing as this is the integrated form. So 1 turns into 3 over 3. So that's x to the 2/3 all over 2/3. And then plug in the 1s and the 0s into it. Well, let me write this first so there's no fraction in a fraction. And then plug in the 1s and 0s. The 3, 2, and then replace x with 1. And then subtract that from the value of replacing x with 0. And that will just give us 3, 2. 1 to the 2/3 is just 1. And then this part just becomes 0. So our final answer will be 3, 2 for this part of the asteroid. But remember, there are 4 sides to the asteroid. We only evaluated for this one side from 0 to 1. So now we have to account for all these other sides. And to do this, we can multiply everything by 4, and we'll have all 4 sides. So 3, 2 multiplied by 4 is equal to 2, 1, and the 2 will simplify with the 4, giving us a value of 6 for the arc length of the asteroid.